Till now we discussed we covered the single line diagram and all electrical equipment sizing and selection. Then we also covered the LVAC distribution, and next we have seen so what are the drawings we have to generate for substation designing, like layout sections by doing the insulation coordination study, and we also check the earthing calculation and preparation of earthing layout, sectional views, and followed by the cable routing layout, cable sizings, and selection, and also the lightning and illumination, everything. So by this, and we also talked about the clamps and connectors. So up to this, so we completed entire the whole concept of primary engineering. So till now, what we discussed, this comes as a under the primary engineering. Primary engineering in the sense, we do preparation of single line diagrams, layouts, all this will comes under the primary engineering. I'm coming to the one secondary engineering. The secondary engineering states that the control and protection for this entire substation we built till now. So we constructed a substation till now. So for this we need to protect. We need to implement a protection schematic, right? So that we have to discuss in our next subsequent classes. So let me tell you the how this will move. I mean, how this 4 classes or 5 classes which requires will progress. So in our first class, we will discussing on the control and controlling of the substation. So in our today's class, we will see the block diagram and a introduction, and also we are looking on the schematics for today. And in our next class, we are looking for on the preparation of cable schedules, and later we are discussing on the different types of protections like overcurrent and fault and all these things, and followed by the distance and directional distance and differential protections, and finally the control relay settings and the ETAP, and we are discussing the some concepts what we left in our earlier classes: load flow studies, short circuit studies, and protection and coordination in ETAP is our last session. So in our today's session, let's talk about some topics, something related to the single line diagram optics. So let's see. This is my 33 kV feeder. 1, 2, 3, 4, 5. These are the 5 feeders, and these are the 5 feeders. 1, 2, 3, 4, 5. These are the 5 feeders. Now these two are connected with a sectionalizer, and we are having a transformer which is connected to a double bus bar arrangement, double bus bar system. And we are having a bus coupler unit here, and the 2 lines are going out from my substation. This is the line 1 and this is the line 2. This is the line 1 and this is the line 2. Fine. So at every stage we are having a breakers. So this is the breaker we have. This is the breaker, and the breaker. This is the breaker. So we are having breakers at every stage of at every branch, right? So let's see in this way. Suppose now if I am talking about this feeder, particularly this 33 kV feeder, this feeder having some protections, could be overcurrent protectional, directional or non-directional. So if you want to, it's totally depends upon your choice, what protections you are adopting here. So we are not much focusing on the protections for today's discussion, but we are here mostly concentrating on the controlling part. So what do you mean by controlling part? So controlling part is, so I am having a breaker here, And either side of the breaker, we are having the isolator, right? And again, we are having an isolator here, right? So now if I want to open up, if I want to open up this breaker, or if I want to open up this breaker, I have to ensure the status of these two isolators. Otherwise, in a simple way of understanding, let's suppose if I want to open this isolator cannot be operated, cannot be opened in a service, right? Oscillator is generally opened in a no load condition. So when I'm trying to open this isolator in a no load condition, so a no load, so I have to ensure the system, yeah, there is a no flow of power in that circuit. So how can I know this? So by checking the status of this breaker, the two ends of this breaker should be in open condition. When these two open, then I can open up this isolator and I can do the maintenance of this breaker. So again, when I'm closing, so these we will call as a interlocks. These are generally we are having the interlocks to further safety, for human safety as well as the equipment safety. So these interlocks are there. So these interlocks and wiring of all these incomings, everything we are seeing in we are looking this in the control and relay panel. So let's see, these are the isolators, two isolators, breaker and CT, PT, all these signals, all the status or the controlling part and protection. So these all should be accommodated in a panel. So this panel we will call as a control and relay panel. All the things which are accommodated in a panel, that we will call as a control and relay panel. So the control and relay panel accommodates all the CT circuits, CT signals, and the breaker status, breaker open closing circuits, breaker tripping circuits, isolator indication, control and indications, AC circuit, DC circuits, DC, I mean the AC routing and the DC routing, and other such other kinds of things, etc. So today we are discussing about this control and relay panel, how the scheme looks, how to review the scheme. So before going into this, so here I need to talk about some concept which is a centralized and decentralized architecture team. So what I mean by centralized the decentralized architecture is, see, I am having a panel here, right? So for this, again, I am having a panel. So every breaker unit having a panels, right? So 1, 5, 10, 11, 12, 13 panels required at 33 kV side, and 1, 2, 3, 4, 5 panels required on my 220 kV side. If let's assume if my protections are general protections. And again, it depends upon the type of protection you are adopted, whether the unit protections having other, suppose on the line cannot be accommodated in one panel. So we are having 2 panels for each line. So that's the next way of, that will come in our next discussions. So for the present, let's assume that each feeder, each breaker is having 1 panel. Okay. So these all the panels where you are accommodating all these panels. Suppose if I am having a control room here, and if I accommodate all these panels in this control room in one room, so what is the condition to be look here? That suppose if I am accommodating all the panels in one room, so all this status, all the cables should be routed or should be laid to this room, right? So it will cost me the cable length is increasing, and these cables are will pass through some trenches. So those trenches, the civil construction, everything also will increases. So it's totally impact on my cost of the project. So this method is called a decentralized one. So all the cables, all the panels are in one room. So all the cables should be routed to this. So what was in the earlier projects in the before in 2000 or before, they are using to have this type of architectures. But presents to reduce the civil cost, to reduce the cable cost, what they are doing is what we are present, all the developers were having a plan that they are having some small rooms which are 3 meter or 5 meter into 5 meter rooms at a height of 3 meter or 3 meter, 3.5 meter is there, 3.5 meter. So these rooms, so what they will do is they will place one room here and one room here, one room here, one room here, and one room here. So what they are doing is they are placing these control and relay panels in this room now. So for all these five are placing in this, all these five are placing in this, and this having both the transformers, and this having the bus bar, bus couplers, all these things, and this accommodates line. So by this, what is the cable cost is decreases. Now only few cables are running through this main control room for the SCADA communication. So SCADA is lying in the control room. So all the cables now are coming here. So only the communication cables are pulling to this SCADA from these panels. So now the cable trench cost is also decreases, the cable length is also decreases. But here you are increasing the civil cost of the buildings. So if you are just analyzing the both the options, obviously this decentralized architecture is a good option for the present scenarios. So until again, so if you want to decrease the cable cost further, so nowadays we can see a substations, a digital substations where no need of cable, only a few cables are coming. So that is also a good advantage we can see in the digital substations which are coming in, which are going to, which are mainly most of the developers focusing at this point. So now we are talking about, so what is the control and relay panel? So we know that how they are accommodated all this. So now let's talk how, what are the cables are coming in this. So how the control and relay panel looks. See, before we need a relays for 33 kV. Obviously, we required at every breaker unit we required overcurrent at fault relays. So before these relays are there are different types of architectures. Means a way of doing this stream. Suppose let's assume in the olden days these interlocks, what we mentioned, like the isolators to be opened. See, this mechanical interlocks, they what they will do is these all hard divided. These are hard wired, and if all these satisfied, then it will give a signal. It gives the output. So this is the hard wiring. This is this will be there in the inside the control and relay panel. So the control relay panel size will be high, will be more in the olden days. But now present with the concept of BCU and BCPU, so this hard wiring everything is reduced, because the BCU is an intelligent IED where inside you can take the status of the breaker, you can take the status of the isolator, and here you can write a program and. If both are and, then give output. If this flag high, then it's giving output to the breaker to trip. So kind of thing. So soft logics. This is a soft logics where you can develop in the BCU. But in the BCPU, along with these things, you can also have some protections like the overcurrent protections, at fault protections, over voltage protections inbuilt in this. So we no need to purchase the relays separately in the BCPU. In the BCU, we have to purchase the relay separately because it's only a controlling unit. Here it is a control and protection unit. BCPU is a control and protection unit. Now, in all the developers across the global, they are going with the BCPU. So the size of the relay panel was decreased So now, if you see for the 33 kV, mostly we implementing only overcurrent and at fault protections. So this is already coming in the BCU. So in one panel, we can accommodate two feeder protections. So in a 33 kV, only for the particular 33 kV, 11 kV, we can see two feeder protections in single panel. You can accommodate like this. So this we will call as now this we will calling as a twin feeder panel. So twin feeder panel, like all the developers are providing this twin feeder panel. So not same, but because of the no requirement of additional relays, so there is a space availability. So the two feeders control and protection can be accommodated in single panel with the help of BCP. So this is the latest one. All the developers looking ahead on this twin feeder panel. So now let's see what this panel. What are the circuits we can see in the panel? So generally, if you are a developer, you can do this schematic drawings in your in house in your company if you are having a E3 software. So to develop the schemes, we required E3 software, which is required to develop the schemes. If your company having this, you can develop easily, but most of the developers will give this exercise for the third parties from where they are purchasing the relays. Suppose if I am purchasing the relays from the ABB, so I will include this also in their scope and will make him to do this one. So these schemes again are standard one. So all the developers are having a standard scheme. So when after developing the scheme, they will provide to us, and we have to review that scheme in deep. So literally, it is a very important exercise in the secondary engineering. The schematic drawing should be reviewed carefully when you receive a document from the ABB or what third party. So if you know what actual inside that, what are the schemes inside the control relay panel, then only you can review that, right? So it's a kind of that. So what we have to see here. So let's see now. Let me show you that. So now I think you able to see the screen. So this is a Siemens one. So this is the panel, how it looks, which is 800 meters back. So here this is a twin feeder panel. They accommodated. See, this is the BCPU for the feeder A, and this is BCPU for the feeder B. And this is the breaker control switch and push buttons. And this is the second feeder control switch and their push buttons. TBM, feeder 1 TBM, feeder 2 TBM. Feeder 1 TDBs, feeder 2 TDBs, all are separate. And feeder 1 DC changeover relays, feeder 2 DC changeover relays. Feeder 1 flip circuit supervisions, supervision relays, feeder 2 supervision relays. So everything is accommodated inside this panel separately. Now, if you just want to know what this 152 T152C tells, you just go and refer to this legend. Come to this 152 and 152C. These are feeder 1 breaker close contact multiplication relay, and this is a feeder 1 breaker trip contact multiplication relay. And if you just want to do for 495 and 395, so again, come to here, you can see, yeah, 495 is a trip circuit 2 supervision relay, and 3795 is a trip circuit supervision relay. And again, we require two more trip circuit for the next other feeder, 195 and 295. So 195, 295, 395, 495, all are trip circuit supervision relays. Fine. And ATC1 are the DC changeover relays. ATDC1, ATDC2 or the DC1 supervision, DC2 supervision relays for each feeder. And if you just want to look into the type of that one, so you can see the type. BCPU is the Siemens one. So 7S85 is the relay of the Siemens, and remaining all or these supervision relays they are purchasing from the ABB. And the meter is a secure make a meter, and resistor units. These are the resistor units, and these are the test terminal block. And for the BCPUA, these are for build case. And if you just want to know the dimension of your panel, so this 800 and the height is 2315 mm. So it's a 2.3 meters and 0.8 meters. So, and if you just look into the top view, you can see the dimension is 800 into 800, and the height you will.
Voice is not clear. It's not audible properly.
Hello, now? Now is it fine? Hello? Now it's fine?